Hi, Assalamualaikum warahmatullahi wabarakatuh. In this video, I'm going to talk about the idea of finding the conditional expectation. So we're dealing with conditional distribution right here. Well, you are asked in this case to find the conditional expectation of a function. So here is a function and that is related to x, and in this case the values of y is given as such. If it is a discrete case, then you will be dealing with a summation process, and if it is continuous, you will be dealing with integration process basically. Yeah. And what you need to perhaps pay attention is that we are going to replace this guy over here with what is known as the conditional distribution of x given y. So here is also the conditional distribution of x given y. Okay, that is basically what it is. And to illustrate the application of this formula, we are going to consider the problem related to discrete case, and then we will move on to the continuous case. Okay, and here is an example of a discrete case based on the joint probability distribution. So this is the table that contains the joint probability of x and y. We're going to find the conditional mean. So whenever you talk about mean, you're talking about finding the expected value. So you're going to find the expected value of the conditional situation right here where y is given equals to 1. So you're going to find the conditional mean of x given y is equal to 1. Okay, okay, so this is discrete case. We're going to refer to this formula right here, and according to this formula, we want to find the expected value of x, okay, given y is equal to 1. So that is what you are asked to find, and this has something to do with finding or something to do with doing this process right here. So this is ux, so therefore this is our x, this is our ux, so we have that written next to our conditional distribution. So we need to find what is fx given y is equal to 1. So you can be specific and write down what is the value of y. So y is equal to 1, and that's it. So that's the formula. So now our job is to find the conditional distribution given here. Okay, now remember what you have seen in the earlier chapter where we talk about the perhaps this part where you talk about the conditional probability when you have a given b. So the idea is that you can find the conditional probability of it by considering the probability of a intersects with b over probability of b. Okay, since b has already happened, we should be able to get the probability of it, and we can supply the information right down here at the bottom. So that was something that you have already seen. And similarly, if you have this guy over here, this is the distribution, this is conditional distribution fx given y, then the similar idea or similar outlook can be seen in this case. So we are going to consider the joint probability distribution of x and y, and then we're going to focus on marginal distribution. So we're just focusing on fy. So fy alone is the marginal distribution. Remember, this is what you have already seen in the previous chapter. Okay, so this is what we need to do now, because we need to find what is this one. This is a conditional distribution of x given y when y is equal to 1. And we need to be able to find this using the formula given here? Well, you can see clearly that this part here is already given by this table right here. So we're going to make use of the table given here. And the bottom part here has something to do with finding the marginal distribution of y equals to 1. So if you want to be more specific, what we need to do is we need to find what is fx given y is equal to 1, and here is fx and y is already 1. We can just replace y with 1, and over here we are looking for a specific value of y equals to 1. Okay, so we need to find the marginal distribution of y equals to 1 really. So that's what we have to do. And I'm not going to explain in details because I've already talked about the idea of marginal distribution and so on in the previous video. So I'm just going to focus on finding what is this part right here. So this part right here is we need to find out from this table, when y is equal to 1, we need to add up all the probabilities here in order to find what is fy equals to 1 really, okay? So if you add this probability, 2 over 9 plus 1 over 6, you will get that equal to 7 over 18. So here is the result. So we have x1, at the bottom here is 7 over 18. Okay, so that is the result. And perhaps what we can do is we can present the result in a table, because we have a lot of different values of x. X here have different values. Okay, as you can see from the table, x can take the value of 0, 1, and 2. So we need to come up with a table to describe this one, the conditional distribution for x given y equals to 1. Okay, so that's what we are going to do. So what we have is, now I'm going to construct a table for that. So here is the value of x. X can be 0, 1, and 2. Okay, and we're going to focus on finding what's the value of conditional distribution when y is equal to 1. So we're going to focus on calculating this part and putting right onto this table. Okay, so when we substitute x equals to 0, so when x is equal to 0, so you substitute that into this part, what is the value of f01? So f01 is this one. 0 and 1 is this value, 2 over 9. Okay, 2 over 9. So 2 over 9 over this guy, 7 over 18. Okay, so I'm just going to write down here. So here we got 2 over 9 over 7 over 18. The result is going to be 4 over 7. Okay. Now, when x is equal to 1, that means you're going to substitute 1 into this position. So we are considering the value of joint probability of f1 and 1. So 1 and 1 is this one. 1 and 1, yeah? So 1 over 6. 1 over 6 over 7 over 18. That is 3 over 7. And then when x is equal to 2, so you're going to substitute 2 into this part. So we need to find what's the value for the joint probability of x equals to 2 and y equals to 1. So the joint probability of that is given by this value, which is 0. So 0 over 7 over 18 is going to be equal to 0. And of course, you can check that your table here makes sense, because all the values have to be greater than or equal to 0. And when you add up all this, it should be equal to 1. Clearly it does, yeah? So we have managed to get this table. And why is this table so important? Because this table will be used in solving this part here, solving this problem. So according to this, we can start on replacing the value of x with its conditional distribution of x given y equals to 1. So we're going to refer to the table right here. So what we have is x can be 0, 1, and 2. So we're going to start with that. Okay, oh sorry. So here we have 0 times f0 given y is equal to 1. And then we have 1 times f1 given y is equal to 1 plus 2 times f2 given y is equal to 1. And all the results here come straight from the table which we have already constructed, yeah? So for this one, 0 times with this guy, because when x is 0, when x is 0, the value is 4 over 7. When x is 1, the value is 3 over 7, and so on. So we're just going to use all the results given in the table, okay? 0 times 4 over 7 plus 1 times 3 over 7 plus 2 times 0. And so the final result of that is going to be equal to 3 over 7. So that's the conditional mean of x given y is equal to 1. Okay, right. Now let's move on to the continuous case. Here what we have is the probability density of x and y. So here is the probability density of x and y together. And we are asked to find the conditional mean and the conditional variance of x given y is equal to half. Okay, so let's start off with finding the conditional mean. Okay, now we need to find what is x given y is equal to half. This is what you are asked to find, and that can be achieved if you consider the integration process, because we're talking about continuous case right now. And what we have is, this is our ux, this is what we need to find, so we're going to put it right next to it. But this one here is going to be the conditional distribution, okay, because we're talking about conditional distribution right now. So we have fx given y is equal to half, and we're going to integrate that with respect to dx. Therefore, we're focusing on this limit from 0 to 1. Okay, now before we can do anything, we need to find what is this guy. What is this conditional distribution? Okay, what is the conditional distribution looks like? Okay, and maybe I should use a different page. Okay, so what we have to do is, we know fx given y is equal to half is going to look like this. We're going to consider the joint excuse me, we're going to consider the joint distribution, joint density of x and y, and here is fy is equal to half. Okay, so we already know what is fxy. Fxy is given by this formula, and you can replace y immediately with half. The value is 1 over 2, yeah. You can be more specific right here, x, and then here is y is equal to half. So we're going to take the joint density and replace y with this value, 1 over 2. So this is the this is the joint density. If you replace y with 1 over 2, the result is going to be equal to 1 right here. So 2 over 3 x plus 1. The result here is going to be equal to 2 over 3 x plus 1. Yeah, 2 over 3 x plus 1, over, okay, so this part is not settled yet. We need to find what is it. Okay, so remember, if you want to find the marginal distribution, so now we need to find what's the marginal distribution of fy, and what we need to do is you need to integrate. Okay, remember, you need to integrate this one, the joint density, which is 2 over 3 x plus 2y, x plus 2y dy, oh sorry, not dy. If you want the marginal distribution of y, you have to integrate that with respect to x. Okay, and from limit 1, 0 and 1, yeah. So that's how you can find the marginal distribution of y, which I have already explained in the earlier videos. Okay, so 2 over 3 is a constant, and we have 1, 0 x plus 2y dx, and if you integrate that, you will get 2 over 3 x squared over 2 plus 2xy, yeah, 1 and 0, and this is 2 over 3 1 over 2 plus 2y. Okay, right. Now what you can do is we know that we need to replace this part here with marginal distribution when y is equal to 1 over 2. So you can substitute. So substitute y equals to 1 over 2. Therefore, fy equals to 1 over 2 is going to be 2 over 3, 1 over 2 plus 1. Yeah, 2 times 1 over 2 is 1. Okay, so what we have is equal to 1. Okay, so that the result here is equal to 1, and we can just substitute the result right here. Okay, therefore final result of this conditional density is 2 over 3 x plus 1. Okay, now we're going to use this result and plug into this. So we have 1, 0 x, and then this result that we have obtained just now is just 2 over 3 x plus 1 dx. 2 over 3 is a constant, you can take it out, and then x times with x squared plus x dx, and the result of that is going to be x cubed over 3 plus x squared over 2 with limits as 0 and 1. Substitute the limits, you will get 1 over 3 plus 1 over 2. Okay, so that one is equal to 5 over 9. Yeah, so that's the conditional mean. So this one is done, conditional mean. Okay, okay, now we're going to move on to finding the conditional variance. And I'm just going to perhaps erase this part because I need some space for it. This one is done. Okay, so now we're going to move on to finding the conditional variance, and the conditional variance goes with this formula. So we need to find what's the variance of x given y is equal to half and according to the formula that you have seen, so it's going to be looking like this: expected value of x squared, okay, given y is equal to half, and then you're going to minus expected value of x given y is equal to half, and you square it. Okay, now this part right here has already been done. We already got the value, which is this one. So this is the value. This is ex given y is equal to half. We have already done it, so we just need to square this value. Okay, we just need to square the value. So that's okay, we're done with that. Now we're just going to focus on finding this one. We're going to focus on finding this value, okay? So therefore, what we need to find is ex squared given y is equal to half. Now we're just going to take this is x squared, and then because this is the conditional expectation, therefore we are going to consider fx given y is equal to half dx, and the limit of dx is 0 and 1. And this value here is the same thing which we have already obtained when we did the first part of finding the conditional mean. So we're just going to use this same result here. So this is the conditional density, yeah? So plug in that right next to x squared. We have 2 over 3 x plus 1 dx. Okay, so 2 over 3 is a constant. We can take it out. And then x squared with x, we got x cubed plus x squared dx. And the result of this integration is going to be as such. And you're going to consider substituting the values 1 and 0 into it, okay? So we have 2 over 3, 1 over 4 plus 1 over 3. And this is equal to 7 over 18, yeah? 7 over 18. And we're not done yet, because what we need to do is we need to find variance. So therefore, variance, conditional variance, which is x given y equals to half, is going to be this guy, 7 over 18 minus this value, 5 over 9, and you square it. Okay, so here we've got 7 over 18 minus 25 over 81. Okay. Which is 13 over 162. Okay, I think that's all for now. Thank you very much for watching, and I'll see you in the next video.